Hello again, it's Jason from STEM Online, where we help students, enthusiasts, and other professionals who want help in advanced mathematics and physics education. Okay, so today we're going to continue what I was doing last time. I want to go more into the course on logic, some very important things that we need to talk about. Um, so far we've talked about truth tables, what's true, what's false. We've talked about going back and remembering certain types of truth tables, basic truth tables, for the and operator, the or operator, the implication operator, the biconditional operator. Uh, and today we're going to actually look at uh, taking a statement, taking two statements, and proving some conclusion. Okay, this is very important. It's in all the introductory logic courses, whether it's for AP or IB courses, and of course in first year university. Whether you took AP or IB or not, it will be in first year university. Okay, so let's look at a logical condition proof here, right? Okay, so if you look at the following, okay, let's say we have the following problem and it has the following premises. Okay, so every logical problem is given the premise. Okay, just 1 second. This pen. It's time to buy a new pen from Amazon. I always joke about that. Okay, so yeah, our premises will be this. Okay, so premises will be the following. So one, we have statement P. P implies in parentheses Q implies R. Okay, that's the first premise. Second premise will be if Q implies that R implies S. Okay, okay, then the conclusion. Therefore, the conclusion that we want to show is that P implies, right? P implies in parentheses Q implies S. Okay, this is what we want to prove. Right? So prove this conclusion. Okay. Now, the way to do that is by doing the following. Okay, we're going to look at using something that you sort of learn in your classes, like modus ponens and modus tollens, and all of that. Okay, if you forgot, I'll go through it step by step so it makes more sense. Okay, so let's look at how we're going to set up our proof strategy. Okay, so let's go down. So the proof strategy for actually doing the proof. This is not the formal proof for this strategizing how to do these. Okay, because if you don't set up a strategy, it can be tricky to prove these actually. Okay, so I'm going to write over here in order to prove. So in order to prove, or to prove that P implies Q, right? That P implies, in parentheses, Q implies S. Okay, we use a two-level conditional proof. Let me just move this over. Need some space here, actually. Yeah, P implies in parentheses Q implying S. We will use a two-level conditional proof. Two-level conditional proof. Conditional proof. Okay. And the way we're proving this, since proving a logical argument, right, has to do with statements, you could actually use this in your everyday life when you have when you, let's say, not arguing in a bad sense, but arguing with someone, you have your point, they have their point, you try to figure out who's correct, who's true or false. You can use this type of format to determine whether or not what you or the other person is saying is making sense or not. Okay, but you have to translate these from symbolic logic that I have here into the actual words. Okay, so the first thing we're going to look at into solving this, because we want to get that P implies the Q implies S. Okay, so we know that's going to be a two-level conditional proof. The first level, right? So the first level assume P and then derive Q implies S. So we have to assume, right? Assume P to later derive, right? To later derive Q implies S. Okay? Implies S. That's the first level. And then the second level is going to be under the assumption of P under the assumption of P, further assume Q. Okay, so further assume what Q is, and then derive S. Then we will derive, right? Then derive S. Derive S. Okay, so there's going to be a two-level state of attack here for the proof. Okay, so let's do it. Okay, let's do the actual formal proof. That was the strategy from the proof. So let's try this step by step here. Okay, so first off, the first thing for level 1, right? Since we want to assume P to later derive Q and S. So that means that the premise. Okay, so for the premise, P implies, in parentheses, Q implies R. Right, we're assuming this. Assume as given. Make sure you're putting what you're doing under each one of these statements. You need a justification of why you're doing this. Okay, assume as given. If you do not put even if this whole thing is correct, you don't put the justifications underneath, then they'll mark the whole thing wrong. Okay, the justifications are more important probably than these logical symbols. Well, they're both very important, but without the justification, you don't have a reason to go from step to step to step to step, right? From one step to the next step to the next step. Because if there's no justification for a step, then there's no logical link from the previous step, okay? All right, so we have, because premise 1, P implies Q implies R, assume as given, because we said our proof strategy for the first level is to assume P, then derive Q implies S. Okay, that's premise 1. Premise 2, right? So premise 2 was to say that Q, right? Q will imply R, which implies S. Okay, because if you remember, what I said earlier was that, right? What I said earlier was that both these are the premises, the two premises that we were dealing with. Okay, again, put assume as given, right? Because we said in our proof strategy that we assume the premises are what they are. So this has to be axiomatic, okay? That has to be axiomatic. Okay, so first two are good. Step 3, I'm gonna have to make some more room here. So step 3, I'm just gonna put them to the side here because we're running out of room. Step 3 is to look at the following. Okay, step 3, assume for conditional proof. So assumption, I'll say assumption, for conditional proof. For conditional proof. Right, so take the assumption for the conditional proof. Assume P. Assume P. Our goal now is to show that it follows. Right, so our goal, here's our going to be our justification. Our goal now becomes to show as follows. Show the following. Okay. I guess you can say this is some sort of justification because I'm showing why I'm going from step to step. There has to be a logical link for each thing. Okay. Otherwise, if there's no logical link, we're in trouble. Okay, so we have this now. Okay, so we have that. Now, what we're going to start invoking is each one of the rules. Okay, step 4. Right, step 4. I'm going to use modus ponens. So modus ponens. Right, modus ponens on 1 and 3. On step 1 and 3. Okay, step 1, we said the premise was P implies in parentheses Q implies R, and step 3 was to assume for conditional proof, assume P. Okay, so it makes sense to use modus ponens because of the fact that from P implies, right? So I'll go over here. Let's go all the way up. Right? Continuing forward from P implies Q implies R by step 1. And the assumed step and the assumed step, which was step 3, we infer, right? So we infer that Q has to imply R, right? So Q has to imply R. But if P holds, if P holds, right? So if P holds, then Q implies R has to hold then. Right? So then Q implies R has to hold. Right? Must hold. Right? By modus ponens, sorry. Okay? All right, then we have, let's see where we are, step 5. Okay, step 5 now. Assumption for the inner conditional. So I have to make now an assumption for the inner conditional proof. Inner conditional proof. For the inner conditional proof is that assume Q. Right? So I'm going to assume Q. Our goal now is to derive S under, so our goal, sorry. Our goal is to derive, is now to derive S under the assumptions of P and Q. Under the assumptions assumptions of P and Q. Okay. All right, let's go to step 6. Okay, so we're going to continue. We're going to continue this part here. Let's see, step 5, step 6. So step 6 now, modus ponens again. I'm going to use modus ponens again. Modus ponens on step 4 and 5. On steps 4 and 5. So if I use modus ponens on step 4 and 5 now, I'm going from Q implies R, which was step 4. Okay, and the assumed, and we'll use the assumed. And the assumed Q from step 5. So next I have to infer, well, not next I have to infer, we just inferred, right? So we inferred, right? We just inferred what R is, okay? Because the justification for that is that giving Q, the fact that it implies R, we conclude R. So given, so given Q, one second here, given, let's move this down, given Q, and that Q implies R, we conclude R. We concluded R, okay. Step 7 now. Okay, so we have a step 7. I do it over here. Step 7. Step 7 is now modus ponens on 2 and 5. Ponens on 2 and 5. Modus ponens on 2 and 5. So what do I mean? So from Q implying R implying S, from Q implying R implying S, right, which was step 2, and the assumed Q, which was step 5, we now obtain, right, so we're going to obtain, so we obtain, okay, so we're going to obtain the following. We obtain R implying S. Since Q is assumed, justification, since Q is assumed, Q is assumed. 1 second here. My pen is acting weird today, sorry. Since Q is assumed, R implies S follows from premise 2. Follows from premise. 1 second here. Follows from premise 2. Okay, so follows, careful, follows from premise 2. From premise 2 it should be. Now that I show that it follows from premise 2, right, then we have to do modus ponens on 7 and 6 for step 8, okay? So now we have to do step 8 now. Step 8 would be modus ponens on, so modus ponens again. Components on 7 and 6. On 7 and 6. Step 7 and 6. And 6. Okay. Okay, so then since we know that with R implying S, which we know from step 7, and R from step 6 is here, and R from step 6, we infer S. Infer. So now we just inferred S, okay? Because the reason for that, for the justification, is if R, right, if statement R holds, then statement S has to follow, right? So then then S follows. Okay. So now we found that. Okay, so now we've done that. There should be one more. No, there's two more. Okay, so there should be two more. I'm running out of room here. I am going to use a long arrow here, so I'm continuing. Okay, so all the way over here. Actually, you know what? I need to make another page here. Yep, give me a moment. Okay, let's make another page. Okay, so next page now. So the next page, we're continuing, right? Because I used up all of the first page. So the next page, we have two more steps that we have to do for justification. So now we have to discharge the inner assumption of Q. So what I mean by that, right? So 9. So 9, since assuming Q from step 5, okay, from step 5, led us to derive, right? Led us to derive S from step 8, I believe, by the rule of conditional, by the rule of conditionals. We can conclude that Q has to imply S. This shows that under the assumption, right? So this will show under assumption of P, if Q is true, then S must be true. If Q is true, S has to be true. S must be true. That's the justification. Final step now, step 10. Step 10 would be to look at the following, right? So since assuming, right? So since assuming P, premise P from step 3, this allowed us to prove, right? So this allowed us to prove, right? To prove that Q implies S, right? So Q has to imply S. That's from step 9. Okay, so from step 9. So we now conclude, right? So we now conclude we have to conclude that P implies, in parentheses, Q implying S. Okay. and this completes the proof. This completes the proof. I believe it's correct because we have justifications for each one of modus ponens and any other logical inferences that we had to use. That's what they're called, logical inferences. Okay. If there's a mistake somewhere, point me out in the comments, but I don't think everything follows well. Okay, so everything is solid. Okay, so I hope you enjoyed that video. If you have any questions, you can contact me in the comments section, in the YouTube comments section, or the website, or anything else. Also, my email, jason@stem1online.com. Yes, and there'll be plenty of more videos coming up. Stay tuned. Don't forget to like and subscribe. Have a good day. Bye bye.